Hello everybody and welcome back to my channel. Today's video is all about Unreal Engine 5.2 PCG. I'm going to walk you through all of the basics so that you can start creating your own procedurally generated worlds in no time. But that's not all. In the end of this video, we are going to put the new skills to the test, so make sure to stick around until the end of this video so we can create something amazing together. Hey guys, it's been a while since I've uploaded a video and I want to explain why. Unfortunately, I had some issues with YouTube and they demonetized my channel and banned my bank account for no reason at all. Despite that I've reached them 14 times, I even talked with their support, I had no luck in resolving the issue. It is frustrating, but it made me realize that I should always have a backup plan. Before I started this channel, I wonder why the big YouTubers had also Patreon where they can have YouTube membership. Now I know why. A simple AI can shut down your monetization at any time. But let's not dwell on this because today I want to talk about why I've created this channel. My goal with this channel is to create a community where people can learn, create, share their work together and just help each other. I want to inspire you to create great things by using Unreal Engine 5 and use my videos like a foundation that you can build upon. My role is to provide you with the knowledge and tools to achieve your goals. And secondly, I want to create the best Unreal Engine community that you can have. So don't hesitate to hop in our Discord server. The community is growing bigger, is growing stronger. There are a lot of knowledgeable people there that can help you out with your project or your problems. That being said, I've decided to switch to Patreon to continue supporting this channel and the community. By joining my Patreon for as little as $4.99, you'll have access to all my files from my videos, you'll have access to the auto material from this video over here. If you didn't watch it, go and watch it, as well as everything that I've created in the past and I will be creating in the future. Additionally, you will get access to a private Discord server which is dedicated to my Patreon members only. But that's not all. As a Patreon member, you'll get exclusive access to in-depth videos that will explain a little more about the auto material and each thing that I'm creating in my videos. So a lot more videos you can find on my Patreon page that won't be shared anywhere else. If you want to support this channel, gain access to all my assets, join my Patreon now. Thank you so much for your continuous support. And now let's get started on our journey through Unreal Engine 5.2 and PCG. Alright everybody, so this is the final result that I've created using the PCG. I've created custom PCG nodes that will mimic a forest, and there are a lot of nodes I'm going to show you right now, but this is the final result that I've get so far. Of course, it is still work in progress and there's a lot of things that can be improved and tweaked, but I'm pretty sure it looks pretty good. I'm pretty pleased with it. So we have different biomes over here. We have different vegetation. We have different trees, different forest. The grass itself looks pretty cool. I've added few flowers on the ground just to break it out. And here we have a little path over here with stones, pebbles over here. All right, some other biomes. And here we have this riverbed where it transitions. And we have some vegetation for the river that grows in moisture area around the rivers. Here we have again the forest, and we have some rocks over here spawning dynamically, procedurally with the riverbed. Everything has collision meshes. You can climb, you can get hit by a tree, you can move over here through those rocks. And here are some other rocks spawned from our PCG node. And pretty much this is what I've accomplished so far, and everything is dynamically spawned. This is a water body that I'm using just to mimic a river. As you can see, our character is getting in this little deep river over here. We have some pretty nice transitioning here over there with the rocks. And let me first show you what we are going to cover in this video right now. We're going to cover how we can create blueprints and connect them with our PCG graph. Let me show you the end result of the forest that I've created. This is only for my Patreon members. I'm gonna include my PCG Forest Pro only for the Patreon members, and you're gonna have access to everything here that I've created. So what I've created for my PCG Forest Pro, I've created two tools for my forest and my road. I've created 11 subgraphs, one for the bushes. I have one subgraph for the forest data, for the grass, the path, the plants, the rocks, the scatter, the shoreline, the shrubs, the trees, and the water. This is all the subgraphs that I've created so far. Of course, I'm going to expand this in the future and share it with you on Patreon. And I've created two nodes for applying density to height and height to density. Let me show you what this forest does. So in order this to work, you need to drag and drop from the tools folder, the BP forest. And here I've created a curve circle with an icon over here. This is the definition of where the forest will spawn. The next one is our BP road. I'm going to place it over here and we have a road icon. What I'm going to do is I'm going to select this one and put my road across this. And by holding out, I'm going to shape it a little bit more to create a little curve. Let me just hold out one more and out. So I'm just crossing across my forest over here, creating this interesting road shape. And the next thing that you need to do is you need to drag and drop the PCG forest over here. And everything will spawn dynamically. All right, looking pretty good. It spawns pretty fast. And what you can see over here, let me just zoom in. You have foliages around the edges. You have some nice flowers over here. Let me just tone down the speed. You have the path over here. I just put those rocks, but of course you can go crazy and put anything you want over here. And the great thing is that if I select my road over here and start tweaking the splines, let me just tweak it like that, everything will change dynamically and the forest will start cutting the road through here. The next thing is that you can expand this forest wherever you want. So I'm going to select this green dot and I'm going to start moving it to the left. So I want my forest to be like that and it will start spawning forest over here. All right, looking pretty good. It is a little bit intensive process, but once it's done, you have all your forest over here. And of course I can expand it over there. And the road right now will start from here, from this point. And if I want to tweak my road again, I'm going to select the road, I'm going to select this spline, and I'm going to move it all the way over here. And it will start cutting through my forest. All right, just a few seconds to compile. All right, and we have now, let me just turn on the gizmos. We have now our path through that forest. And it looks pretty amazing. I've played a lot with the trees to get this homogenic nice look and have this density over here, and the grass, it's looking pretty good. The next thing that I want to show you is in my PCG subgraph, I've added a PCG water layer, this one. Let me just show it to you. And in this PCG water layer, I've tagged here that you can select actor selection class, and the water body river and the water body lake will exclude and will start deleting trees when you spawn them. So how to add rivers to this pretty nice forest? You go over here and search for river. I've already added the water plugin in my Unreal Engine. So you go to plugins, you search for water, water extras, and water. And the next thing is go here, search for river, drag and drop the river body over here. It will take some time. So now when you have your water body river, again, you need to select a point of the spline and you need to make that point to go through your forest. So I'm going to make it go through everything over here and wait a few seconds. And once the PCG finish, you can see how this water river is going through your forest over here. And it creates some water plants, it creates some rocks aside of the river. Of course, right now I'm a little bit high over here. I can put it a little bit down. And that's how the water layer is also working with our PCG Forest. So this was the little demo that I want to show you, and enough talks, and let's deep dive and show you how you can create this. All right, everybody. So we're going to start with the basics of the procedural generated content, and then we're going to advance and create some more complex stuff. So let's start. This is a terrain that I've created in Gaia. If you don't know how to do it, just watch my previous videos. So right now, what you need to do first is you need to enable the procedural generated plugin. So you need to go to Edit, Plugins, and search for Procedurals. Once you find it, it is under Procedural Content Generated Framework. It is still in beta, so there could be bugs, that there could be upgrades to it, but right now it is a version 1.1 and I'm using Unreal Engine 5.2. So this is the version that I'm using, and if you're using a later Unreal Engine version or a higher version of the PCG, there could be some changes. All right, so enable it from here, then reset your Unreal Engine 5. I've already did this. And now let's create our first graph. So I'm going to right click here and you have a new tab PCG and click on the PCG graph. I'm going to name it PCG basic graph. And when I double click, it will open a new menu. It looks like the blueprint system, but it's a little bit different. On the left side, you have a lot of different content that you can drag and drop. So those are the functions. So let me just drag and drop some of the functions. So this is density noise. You have a lot of different things that we're going to talk about. Another method to add blocks is right click and search for it. So let's say surface sampler. I'm just going to search for this. Click on it and you add the block. It's very similar to the blueprint system. The other thing is when you click on a node over here, on the right side, you have all the parameters that you can change per node. And each node has a lot of options added to it. All right. So this is the first thing that I need to explain here for the PCG. It looks just like the blueprint system. So let's start by creating a surface sampler. I'm going to right click. I'm going to create a surface sampler. Here in the input, you need to start from this node. I'm going to expand it. And I'm going to input my landscape to my surface over here. I'm going to connect my landscape. Also, you have landscape height, so you can connect the landscape height to any nodes and create some logic behind it. But first, I'm going to connect my landscape to my surface. I'm going to hit Q to align them. And now I'm going to save it. Always save. And how to add your PCG to your scene, drag and drop it over here. And you're going to see a bounding box. This bounding box represents the place that your procedural generated content will be spawned on the map. If I make it bigger, let's say like this, so it will cover this place. And right now you don't see anything on it. So how we can see something that is happening over here? I'm going to select this surface node. I'm going to right click and choose debug. And right now we see some boxes over here, some cubes with different colors. So we started to create procedurally generated stuff. And if I start moving them, they're connected to the landscape. And this is because we've connected the landscape over here to the surface sampler. So the surface sampler is taking information from the landscape and it's procedurally generated our cubes based on the volume that we've presented. And it's following the landscape surface. All right. This is pretty cool, pretty good. So good so far. Right now we have different colors for the cubes, which represent different values. It is just in the grayscale of 0 to 1. And based on that, we can spawn different things. So let's say we want to spawn different palms on the black and different trees on the white, and we can do that. So this is the surface sampler. You can turn on and off the debug option by pressing D on your keyboard. And now let's talk about the different options over here. So if I start scaling up my cube, and you can see that it is covering more and more of this surface. But if you want to cover the whole surface and not to have this bounding box, you just need to click unbounded. Be careful with this because it's going to cover everything in your scene, and this could be quite expensive and it could crash your Unreal Engine. But let me click it. You just need to wait a little bit so it can calculate. So right now, when I turn on the unbound, you can see that everywhere we have these boxes over here spawned. So this is what unbound do. it will spawn the procedurally generated content on whole area of your landscape. I'll turn it off because it's heavy on the performance, and let's focus on this one. So there are also other parameters. You can extend the points. For example, if you want on X to be a little bit big over here, you can do that. For example, if you want a wider tree or you're creating some walls, etc., you can extend with the points over here. Oh, let's try with 20. You can see how I'm shrinking them. And on 100, it will be like cubes. The next thing is looseness. So looseness will tell our points how to act to each other. You can create bigger spaces between them, as you can see over here. Even bigger spaces. Let's try with 5. You have few points over here. So let's bring it to 1. So from here, you can create different variations and spacing between those points. So this is the basics about our surface sampler. And let's move on. If I expanded it, you have a lot of options over here where you can find different nodes and connect them over here and create different logic. And the final thing is you can use the seed to pre-generate the cubes over here and create different shapes. All right. I'm going to hit D on my keyboard to turn off the debug. Next, what I want to show you is the transform points. So I'm going to right click, transform points. So this one, transform points. And let's start the debug over here. Turn it on. And let's connect my output to the input of the transform points. Here you have a lot of options. You can offset them by min and max. You can rotate them. You can scale them. You can use absolute scale. You can recompute the seed, etc. So the things that you're going to use are here the offset, the rotation, and the scale. I'm going to show this a little bit late when we connect trees. But from here, you can apply this different transformation to your objects. Now let's move on. I'm going to create a density filter. Density filter. So this density filter will filter black and whites over here. So I'm going to connect it over here and click D for debugging my density filter. And turn off the surface sampler by clicking D on it. And right now, we have lower bounds 0.5 and 1. So we are filtering the black colors. And as you can see, we have the silver, which represent 0.5 and 1. So for example, let's say here at these points, we want to spawn rocks. We're going to filter only those colors. We're going to spawn rocks. And on the other density, and I'm going to add another density filter. And we're going to spawn, let me just duplicate this one and connect it over here. And let's say on the lower bound 0 to 0.49, we want to spawn trees. I'm going to hit D here, and I'm going to hit D to turn it off. Right now, this will be for my trees. This will be for my rocks. And see how we can filter the colors and create different meshes over different colors. And this will be very useful when we create different biomes, and it will be procedurally generated with a lot of details. All right. The next thing that I want to show you, we're going to come back to all of this when we spawn some geometry, is the density noise. Density noise. I'm going to turn this off. So right now, we've isolated this by 0.5 and 1. But when we add another density node, we're going to recalculate and create black and white from 0 to 1 again, so we can filter again. So I'm going to turn this debug on this one and turn this off. And right now, as you can see, we created from those points that we filter, we've created new points with different colors from 0 to 1. And we can create another density filter and we can add more geometry and filter it like that. This will be very practical. This is very important. And later on, you're going to see how we're going to spawn those nice meshes and we're going to create amazing biomes. And the next step that I want to show you is how you can spawn mesh. So you're going to search for static mesh spawner. This will spawn our mesh, connect it over here. And here from mesh entries, I'm going to hit plus. And we have a lot of options for our mesh. And we're going to choose a static mesh. There is a PCG, default static meshes. So I'm going to choose, let's say, tree number 1. This is just for the testing purposes. I'm going to choose it. And right now, as you can see, I'm going to turn off the debug on this one. we've spawned some trees over here. And if I select this bounding box and start moving it, our trees will spawn on the mountains. But right now we have a big problem. As you can see, they're spawning sideways. How to fix this? You're gonna go back to your transform point and you're gonna click absolute rotation. And now the rotation will be absolute and it will face the up vector over here. And let's start working with this transform point. What we can do over here is, let's say the scale min and max to be different so we can have different shapes. Let's try with 3 and let's try with 0.3, 0.2. Right now we have different sizes of our biomes. We have 3 for our trees and we have small trees. And this is how you can create different biomes and some nice shapes over here. Of course, we can use the rotation max. Let's try with 90. So you can see how we're rotating on 90, but let's try sideways, 90. See? So let's, for example, this is on a cliff and it is hanging. You can filter some of the trees and just rotate them by 90 degrees, or you can rotate them by 30. Let's try minus 30. So now we are creating different shapes from minus 30 to 30 and we're just rotating them. Pretty cool. Also, you can use the offset by placing some offset over here. The offset is working. They're offsetting from the boxes. So right now they're offsetting with how much I put, with 500 points from the origin of the boxes. All right. If I put 0, we're just moving them to the original position. All right. The next cool thing that I want to show you is how you can debug your graph, and you can enable and disable blocks. If you right click on it, there is an option to enable. And if I turn it off, this block will stop working and we're going to have only the density noise and our static mesh spawner over here. All right. So we are not filtering over here the colors and we're spawning everywhere those trees. All right. So by using E on our keyboard, which is enable and disable, you can test different things. You can turn them off or turn them on in order for you to see if there's some problems and for easy debugging. All right. And right now, let's add another tree to our density filter. So I'm going to duplicate the static mesh and I'm going to choose, let's try with number 3, connect it over here. And we've spawned some other trees, but we have a little problem over here because the density is too high. Let's try with this one. So we can create some other variations of the trees, and let's start and try to debug them. I'm going to hit D over here. So from the black boxes, we're spawning those trees. All right. And right now they're pretty dense. So I'm going to select my density filter on the top and I'm going to shrink it down so we can filter some more. And right now we've created some nice biomes over here with different shapes. And if I want to scale this up, I'm going to scale this up like that. And it will start spawning my trees like that. All right. And we've created this pretty dense forest. Let me just turn down my camera speed so we can see it. So this is just the start how you can use the PCG graph over here in order to create different stuff and mix them together. Those are just the basics. We're going to deep dive as we progress through the video. And one final last thing that I want to show you is how you can debug those points. So let me just turn the points on from the transform point, and I'm going to disable this one. I'm just disabling the meshes over here. So right now we have those points over here, but if we want to know the exact coordinates of them, we can do that. So I'm going to right click and click on inspect. The hotkey is A on your keyboard. When you turn it on, you go over here to no debug object selected and select the PCG basic graph that we've spawned on our scene. And right now, let me maximize it. You can see each of the point where it is on our landscape over here, right? So this is for debug purposes. You can see the scale, Y and Z, etc. Everything here, like information, is shown. And if you want to debug something, you can access it from here. All right, guys. So this is the basics. Let's continue on with some more advanced stuff. So now let's continue on and let me show you how you can work with splines and PCG and how powerful this is. So the first thing is I'm going to create a new PCG graph. So I'm going to right click PCG graph and I'm going to name it PCG basic spline. Basic spline. All right. I'm going to open it. And here in the PCG graph, the first thing that I want to get is I want to get a spline data. So I'm going to right click, get spline data. And from the get spline data, we're going to get the data from a blueprint with a spline and apply it to our PCG. So what we need to do here is we need to actor filter and we need to filter all world actors. So we need to filter everything that is in our scene. All right. And I'm going to filter it by actor selection tag. I'm going to name this basic spline. And this will work for filtering the specific spline that we're creating. So the spline that we create, we're going to give it a tag name with a basic spline. So I'm going to save right now. And the next thing is I've created a folder PCG blueprints. So here I'm going to create different blueprints. I'm going to right click, go to my blueprint over here, blueprint class. I'm going to choose actor over here. And this actor will be BP basic spline. Basic spline. All right. I'm going to double click on it. And here is our blueprint of our spline. I'm going to turn off the tick enable over here. And from the add menu, I'm going to search for spline. Spline. I'm going to add it over here. And I'm going to name it basic spline. After that, I need to select my basic spline over here and search for the tag option. And we've added a tag, which is basic spline. Basic spline. And this is how we filter it. So if I go to the basic spline graph, I'm going to close this one. Here we've created this selection tag, basic spline. And the same tag is applied over here, so we can filter this out. All right, so I'm going to save and compile. And right now our BP basic spline is ready and our basic spline get spline data will work. The next thing is I need to delete my basic graph over here. I'm going to drag and drop my blueprints here, the BP basic spline, and I'm going to drag and drop my PCG basic spline over here. And right now what we have here is a spline. Let me just move it all the way up. And let's continue on with the graph. The first thing is we need a spline sampler. This is just like the surface sampler, but it will sample a spline. So I'm going to right click, search for spline sampler. I'm going to connect it over here. And I need to make a few changes. The first thing is the dimension. Over here, you can choose different dimensions of the spline. You can go along the spline. Over here, let me just show you how this works. I'm going to hit D on my keyboard to debug it. And I'm going to focus on my spline. So with using the dimension on spline, if I turn the debug on, you can see that it is moving along this spline. How to create another spline is select this point, hold Alt on your keyboard and drag. So here, like that, you're creating different splines. And right now, what we've created here is all the PCG components are at the spline curve. They're going along the spline curve. And what you can do over here is you can increase the subdivision per spline. And this will smooth out everything and it will spawn a lot more splines over here. This could be useful for paths, etc. But right now I'm trying to create an isolate forest. And how to create this is I'm going to put this one. And for the dimension, I'm going to choose interior. And right now we have an error. And the error says interior sampling only generates for closed shape. Enable the closed loop settings on the spline. And what we need to do is select our blueprint over here and select our basic spline here, the object, and search for closed loop. I'm going to select this. And right now, as you can see, we are spawning here at a closed loop. What I can do over here is I can add a transform point. In order to scale this down a little bit, let me just connect it. And for the scale min and max, let's try with 0.2. And here again, 0.2. And let's start debug this one. And right now, as you can see here, we are spawning points at the transform point. Let's try with 0.5. 0.5, 0.5. And we are just spawning points inside the circle. Let me just expand this a little. Let's make it bigger. Let's say this is our forest. Let me just move all the way here. Expand this. I've created a lot of points, so I can create pretty interesting shape. Just like that. So here is our forest. And our transform points are like that. But right now, everything is so even. For example, if we try to spawn big trees and small trees or some bushes, everything will be spawned like that because we are using just the white color. And we need to balance this out. We need to create variety in our grayscale from 0 to 1. And this can be done by interior density falloff. So we need to add 2 points over here. Right click, add key. And time and value, I'm going to put 0, 0. So this is the start. And I'm going to add one more key at 1, 1. And right now, I click those two in order to zoom in. And right now, we are creating variety. For example, this white will be our bushes, and this will be our trees. All right. But here we have a problem. If we start scaling this up like that, see how not even it is? Here we have a lot of white, and here we have some dark. And we want this to be even. When we start shaping out our things, right? It is not even at the edges. And how we can do that? The first thing, you can reverse it, of course, with a density ramp. So for example, if you want black to be out, you can just switch this out. So let's say this is 0, 1, and let's say this is 1, 0. And right now we just flip them, all right? And to even everything from the border to the center, we need to create one more spline sampler. So I'm gonna duplicate this one, and I'm gonna connect it from the get spline data. And as I've showed you, we need to create geometry around our spline over here. So I'm choosing our spline. And for the mode of subdivision, I'm gonna change it to distance. Now when I zoom in over here, let's try debug it. Turn on the debug. Turn off here the debug. We see that we have some splines over here. Turn it off and on. We have these little bit boxes. Let's try to increment the distance a little bit to 300 so they can be filled up. And we create this good shape over here. And this will determine the distance from the side of our spline to the middle center. And we can simply do that by adding a distance node. So I'm going to right click distance node, and we're going to filter this distance, and then we're going to connect it to our transform point. Connect to our transform point, connect this to source, connect this to target, and our distance, let's try to debug our transform points over here. And for the distance, max distance, I'm going to use 1000, and I'm going to set my density over here, set the density. And right now you can see the difference. We have even spaces between the black and whites over here when we debug this. And let's test this out. I'm going to move this a little bit inside, a little bit outside, and see how everything is pretty even. This is the effect that we want. So we've created our forest over here, and it looks pretty good. Everything works like a charm. And the next step is I want to show you how you can create paths in order to cut through the forest. In order to create the path, we need to create a get spline data. Get spline data. All right. And this time I'm going to choose again all world actors, and I'm going to create a new tag which will be a path spline. All right. Now, as before, we need to create one more blueprint. So I'm going to create a new blueprint. I'm going to choose actor, and I'm going to name it BP path spline. Path spline. All right. I'm going to double click on it, and I'm going to add again spline. And I'm going to name this path spline. Okay. We're going to search the main object. We're going to turn off the tick enable. We're going to search for the tag. We're going to add the tag. And our tag was, I'm going to just copy it, path spline. I'm going to paste it over here so it will know which is the tag. And the next thing that we want to do on our path spline is we need to search for scale. And here in the scale, I want to enable scale visualization width. So this will look like a path over here. All right. This is UI just for looking like a path. So right now we have everything ready. We have our get spline data. Let me save it. And now what we need to do is, again, we need to drag and drop our blueprint in order to work. I'm going to save it. I'm going to enable, disable it in order to refresh it. And the next thing is we need to create another spline sampler. Line sampler, right? And connect it to our path. I'm going to align them with Q. And this time our spline sampler will use the distance and will be on spline. So now let's select the BP spline, focus on it, and here it is. I'm gonna move it like that. Let me just minimize this. And I'm gonna rotate it a little bit like that, 90 degrees. And I'm gonna start dragging those points. I'm gonna select this point and I'm gonna start dragging across my forest over here. So I want to try to cut it. Again, if you want to create more points out on your keyboard, drag and drop. And I'm creating some points over here. All right, this will be my path. Keep in mind that you can scale it up. So if I start scaling it up like that, I'm creating more wider spaces across my path and more narrow. But right now, nothing is happening because we didn't create the complete logic, but I'm just creating the path itself first. Now what we need to do is open our basic spline and debug this one. And here we have this cube that is coming across in our spline. And we need to create the shape to be starting from each of the edge of the spline. So we need to create another node which will be bounding our modifier. So I'm going to right click, bound modifier. I'm going to connect it over here. And by using this bound modifier, we want our road to cover all the edges of our spline, of our road spline. So I'm going to debug this one, turn this off. And I'm going to start playing with my bounds min and max in order to cover everything. So here is 100, 100. Let's try this one, 100, 100. This is too much, so 50, 50, 50, 50. This is again too much, 20, 20, like 20, 20. A little bit more, 25, 25. It will be 30, 28. 28 is perfect. This is how I find my perfect size. So right now it is intercepting, but only on width. I want to intercept better on height, so I'm gonna tune this up to 100. All right, right now we are intercepting and it doesn't do anything. This is because we still not filter this out, and how we need to filter it, we're gonna create a difference. The people who work in 3D softwares know what difference does. For the other people, this will isolate those forest things that we're creating, this forest with the path, and it will exclude the path itself, and it will start removing the boxes from the forest. So we need to feed the source over here, add the source, and we need to feed the bounding modifier. I'm gonna disable here the debug, disable this one, and I'm gonna enable the difference. And right now the difference is at minimum. What we need to do is we need to select binary over here, and it needs to be interfere, all right? And right now everything is working. We're interfering with our bounding boxes. You can see how this is working, but another mistake that I've done is I didn't connect the transform. So I'm just gonna connect transform over here, delete this connection and connect it like that. And this is because I didn't transform the boxes over here, the cubes. So right now everything is working. We're creating path and this can be updated in real time. See, if I select this, create the size like that, we're creating more path over here, a bigger one. Let's say here you have a little village or something like that. If we start moving this, we're cutting through all the boxes, and keep in mind that those will be procedurally generated and we're gonna create everything looks perfect. And finally, another thing that you should keep in mind is if you duplicate this path, for example, we have this path, but I want to create one more parallel to it like that. And let me just delete this point and let's create a little different shape. Let me just Minimize this one. So right now it is not working, the second path, only the first one. If we start tweaking this up, this is working and my second path is not working too bad, all right? And this is very simple fix. There is very simple fix for this. Just select your get spline data and select multiple, and this will work. The same is for our basic spline. If we duplicate this one and we created another forest somewhere else, you need to select get spline data, select multiple, save it, and it will work. All right, pretty much this is about splines, and those are very powerful, and you can create a lot of different stuff by using those splines. All right, so let's continue on and move on more advanced stuff. Alright guys, so we're gonna move to the next thing. Right now I'm gonna show you how you can create this rock and scatter things around it. Alright, this will be very useful to create different objects and scatter some additional details around them. So for example, this rock, see how it is and how you have a little grass and a little pebbles over here. We're gonna create this, and of course you can use this for anything that can pop out in your mind to modify this PCG. Alright, so I'm gonna minimize here. I'm going to right click and create a PCG graph. And I'm going to name this PCG graph PCG scatter graph. All right. I'm going to drag and drop it onto my level. Okay. And I'm going to double click and start modifying a few things in our PCG scatter graph. So we're going to start with a simple surface sampler. I'm going to right click surface sampler. I'm going to connect my landscape over here. This will start spawning my cubes. I'm gonna click D on my keyboard to debug it. So right now we have the basic surface sampler. Now the next step is I want to filter with a density because I want only the white ones so we can create these big rocks. So I'm gonna add a density filter. I'm gonna connect it over here. And for the wall bound, I'm gonna put 0.9. And once I've put 0.9, right now I'm debugging the surface sampler. So I'm gonna right click, debug with the hotkey D. And I wanna start debugging this one. I'm gonna hotkey D over here. All right, so we have some rocks over here, but I want those three not to intercept. So I'm gonna use the seed over here to create a little bit randomness over it. Yeah, that is the perfect one. Okay. So right now I'm just filtering the high density stuff from the lower bound of 0.9 to 1. You can do, let's say, 9.5. All right, this will be better. So you can have fewer of those rocks. Let me just tweak a little bit more of this. All right, this is the perfect one because we have enough space around them. Moving further, I want a little bit randomization over here. So I'm gonna right click and use a transform points. Transform points. All right, this is the one that I want to use. I'm gonna connect it over here. And for transform points, I wanna have a little rotation over here, 90. And I wanna have a little scale. So 0.1 all the way up to 2, okay? And you don't see any result over here because we're debugging the density filter. I'm gonna turn this off and turn this on. And right now we have some working rocks, but those are pretty small. So I'm gonna raise up a little bit the scale min to, let's say, 0.6. So I can have a little bit bigger rocks over here. And right now we added a little bit of randomization over here by using the transform points. Now we want to create those scatter points, and we're going to use a grid for it. We want to create this grass, a little pebbles, a little rock over here maybe. So I'm going to go all the way up here, and I'm going to use create points grid. Create points grid. All right. And this will create a grid with points around my big rocks. All right. And what you need to do over here is you need to use the Woco and Woco inverse transform. You're going to turn this on, and you're going to go all the way down. And for the scale method, you're going to choose absolute, and you're going to put for point scale 0.5. So we've set up our grid, and now we need to create a bounce modifier. Right now, we cannot debug this. So if I put debug mode here, nothing is happening because we still need to create a few more things. So the next step is to create a bounce modifier. So I'm gonna right click bounce modifier. I'm gonna connect the output over here. And for my bounce modifier, I'm going to create a grid 10 by 10. So here I'm going to use 10 by 10 everywhere. So my bounce will be from 10 to 10. And we're going to use the scale over here. And now is the time for the big truth. And is this going to work? What we need to do is we need to combine those two. So I'm going to combine them by using copy points. This will copy the points from here to here. So our source will be our grid and our transform points will be our target. All right. And now I'm going to select this one and hit D on my keyboard. And now we have some other objects scattering across our rock over here. All right. This is our rock and we scatter some objects. But right now it looks pretty rigid with these grids and it's not looking good. So we need to modify a few things in order to get this nice result over here. The first thing is, of course, we're going to do another transform points, and we're going to connect the output from our copy points to our transform points. And I'm going to start shaping a little bit the offset to -20, -20. I'm going to put to max to 100. I'm going to rotate them by 360. And now I'm going to start debugging this one. So I'm going to turn this off, turn this on. And now we have a little bit of randomization in our points over here. See, it looks pretty good compared to our previous grid that we've created. And the next step is to create a distance. So I'm going to create a distance and I'm going to connect my transform points to my source over here. And I'm going to connect my transform points, which are the big rocks over here, the big rocks, to my target. And I'm going to start filtering a little bit the distance over here. So I'm going to put for my maximum distance 400 and I'm going to use the set density. I'm going to turn this on by using D on my keyboard. And now we start filtering colors by distance. All right. So we are creating this fading effect. And for example, let's say here at the black, you want to spawn a little grass. Here at the silver, you want to spawn some of those rocks, let's say some pebbles. And here you want to spawn something else. And you can use this variety of colors to create different meshes over here and create this variety around the rock. The things that are around the rock, this green grass, this a little bit smaller grass, this moss over here, you can create all of this by using the color from black all the way up to white. All right. But right now this is a little bit too much, so I want to use another density filter. I'm gonna connect it over here, and I'm gonna filter out some of the values. So I'm gonna put 0.128, and I'm gonna put 0.172. Let's try to debug it. Let's turn this off, and we start debugging some of them. And right now we delete a lot of points. So what I need to do over here is I'm gonna invert the filter. So I started filtering by those bounds and I'm going to invert it. So I deleted this spectrum of the color from 0.128 to 0.172. So this spectrum is filtered out right now. This is how you can filter out stuff. So let me show you how you can filter out more of these. All right. So right now we are filtering 0.16 to 0.89. And as you can see, those are below the lower bound and those are above the upper bound. If I go all the way up here, we are filtering everything. And here you can start spawning some things over here. And here you can start filtering. Let's go all the way to the lower bound over here. So this is how you can start filtering. And of course, you can add another density filter on top of this density filter to filter something else. But here I'm gonna put the values that I want, right? And it's still not looking pretty good because those are pretty small and I want a variety in the scale. So what I'm going to use is a scale by density. And this is an execute blueprint. So I'm gonna drag and drop this over here and I'm gonna search for scale by density, this one. And now we're gonna start creating scale based on the color variation, all right? So the min will be 5, the max will be, let's say 0.5, and the density exposure 0.7. Now let's debug this. D on my keyboard or right click debug over here. I'm gonna turn this off. And right now we've created some interesting things. So here we have big grasses, here we have small pebbles, and it looks pretty good. So we started scaling by density. Here you can change the values, but those are good for me right now. And the next step is we need to create a little bit difference between those because the blacks are intercepting the big rock. So I want to spread them a little bit out. So I'm going to do this by creating another bound modifier. So I'm going to drag and drop over here, bound modifier. This is from my rock. I always try to keep a clean graph over here so it is pretty readable. And I'm going to put some values of 0.7, 0.09. Here will be 1. And those will be my points, all right? And now we're going to create the difference. We're going to start cutting those intercepting. So I'm going to create difference, connect my scale density over here, and connect my bounce modifier to my difference. And here in the difference, what you need to do is you need to select binary and the rest leave it to default. I'm gonna debug this one. I'm gonna turn this off. And right now we start filtering the ones that are intercepting. And of course you can tweak this by using the bounce modifier. Let's try with this one. See how they start intercepting. You can tweak this one too. You can tweak this. You can tweak this one. And this is how you filter out the interception. You can play with the bounce modifier settings over here in order to get your desired results, all right? But I'm gonna keep the settings that I've put over here. And this is something that I pretty much like over here. And right now it looks pretty good, all right? One last thing that I wanna show you is how you can self-pruning. So for example, those two are intercepting and those are intercepting. If you want to get rid of this, you can use a node which is called self-pruning. I'm gonna connect it over here and you can prune by radius from large to small, from small to large, etc. So I'm gonna debug this one, D, and you can see that we start prune all the things that are intercepting the others. And you can create varieties from here, over here, all right? If you want this result, of course. So this is pretty much how you can create that thing. And of course, play with each of the settings to see how it will affect your graph and how it will affect your scattering process. But this is pretty much how you can get this effect, this big rock, and spawn things around it. We're going to use this in order to create our final scene. So let's keep going and create the next PCG. Alright everybody, so in this next part I'm going to show you how you can create subgraphs and combine different graphs together. So let's just start. The first thing is to create a subgraph. I've created this folder under my PCG folder which is called PCG Subgraphs, and here I'm going to create my different subgraphs. I'm going to right click, go to PCG, PCG graph, and I'm going to name it PCG Subgraphs. Alright, so this is my PCG Subgraphs. I'm going to drag and drop it onto my scene. And I'm going to open it right now. As usually, we have our input and output over here. And what we can do is we can go to our PCG graphs, and here we can drag and drop previous graphs that we've created into this subgraph. So I'm just going to select my basic spline and drag and drop it over here. All right, and right now we have in this subgraph added a basic spline graph, which is pretty cool. And the next thing is to create a spline. So I'm going to go to my BP basic spline. I'm going to drag and drop it over here and create a few points, maybe like this. And I'm going to close the loop. Select my basic spline, close the loop. All right. And right now, nothing is happening. And what you need to do in my PCG subgraph is connect my input to my PCG basic spline. And after that, I'm just going to create a density noise over here, density noise, in order for us to visualize everything. Connect the density noise over here and click D on my keyboard. And right now, our subgraph has something going on. All right, we have some points and it is working pretty cool. And I want to filter out a few of those because I'm gonna scatter things. We're gonna use this PCG scatter graph later on. So I'm gonna search for density filter over here, and I'm gonna filter out for the lower bound 0.9 and for the upper bound 1. I'm gonna save. stop the debugging over here and start the debugging here. All right, so we start filtering out few things. The next thing is to use our PCG scatter graph, but I'm gonna duplicate this one and call it PCGI scatter graph. I'm intentionally creating this. This is like an instance to my PCG. I'm duplicating this one and I'm gonna start changing few things here in this one. That's why I call it PCGI, like an instance scatter graph, because if I want to use this one for other purposes, I still have it. So I'm gonna drag and drop my PCGI scatter graph, and I'm gonna connect my density filter to the inner connection over here. And if I start debugging this, we're going to see nothing because we need to create some changes in our PCGI graph. So I'm going to double click on my PCGI and I'm going to maximize this. Right now, what we are doing is we are getting the landscape data and feeding it to the simple sampler, density filter, and transform points. And what I want to do over here is I want to get rid of those three. But first, I want to reconnect this, which is going to my transform points, and I want to reconnect it to my input over here. All right, so I'm holding Shift on my keyboard and reconnecting everything over here to my in. And I start deleting those things over here. And this is the graph that we have right now. All right, pretty cool. I'm gonna save. I'm gonna minimize over here. I'm gonna save. Let's try to debug it. So the debugging is really not working over here. And what I did, like a mistake, I need to connect my output also to my self-pruning. So I'm going to connect my output over here, save it, and now it should work. Yeah, now we are start to scattering some things around our white boxes over here. All right, looking pretty good. So right now we've connected our PCG basic spline with our PCG scatter. And what we have here is if I create or move those points, we start scattering those things, those boxes over here, and we are creating some density over here. But another thing that I want to show you is how you can combine the path spline too. So I'm going to go to the PCG blueprint and I'm going to drag and drop my PCG path spline. And I'm going to create a little path over here that I want to intercept with this geometry and remove it. Let me create one more point over here, just like that. And right now, as you can see, nothing is happening. And we need to do some modifications in order this path to start cutting through our, for example, let's say forest. So what you should do is go to the PCG basic spline, open it. And in our output, I'm going to maximize this, select our output. And here in the custom pins, I'm going to add one more custom pin. And I'm going to name it path mask. This will be the masking of my path. And the type should be points as we are using points. I'm going to save this. And I'm going to go back to my PCGI scatter graph. And what I need to do here is I need to add one more for the input. And from here, I'm going to click on the plus. I'm going to extend it and name it path mask. This will be the mask for my path. And I'm going to choose the points. All right. And here we have a difference over here, but we need to create one more difference after the self-pruning. So I'm going to maximize this, move it a little bit like that, duplicate this difference, connect my self-pruning here and connect my output over here. And I'm going to disconnect them. So connect them like that. And right now we need to connect this difference to the path mask that we've created over here. So I'm going to try to connect it like that. And right now it's a little bit messy, so I'm gonna clean up everything to look pretty nice. I'm gonna move it a little bit like that. So right now we are creating a path mask that is going to create the difference between our PCG scatter and our basic path. All right. I'm gonna go back to my PCG subgraph, save this, and here in the PCG scatter graph, I'm gonna create one more density noise. I'm gonna duplicate this, connect this over here. So we use this for debug, save it, and let's test this out. Click to debug here, and right now nothing is happening. And this is because I did not connect my PCG basic spline to my PCG scatter graph, PCGI scatter graph. So I'm gonna connect it over here, move it like that. and it should work now. Right now, we don't see any result, and this is because our road is too narrow. So I'm gonna save this, minimize this, and let's start creating a real space in our road. And you can see that it starts removing some points over here. And we've created this intersection. All right. So this is basically how you can create subgraphs and how you can combine them with your path over here to work interactively and real time. All right, guys. So let's continue on with the next topic. So let's continue on with the next thing that I want to show you. I want to show you how you can connect your blueprint to the PCG. So I'm going to create one blueprint and I'm going to connect my PCG to my blueprint, and then you can have access from the PCG to the blueprint logic and vice versa. This will be cool. So let's start. I'm going to right click here. I'm going to create a blueprint class under the actor, and I'm going to name it BP PCG. All right, this will be my BP PCG. So this is a blueprint that I've created. I'm going to save it over here. And how can we add a PCG component here? From this button, add near the component, we search for PCG. And you can add a PCG component over here to this blueprint. All right, we've added it. And now here at the instance, it will ask for us to hook up a graph. So I'm going to go to my PCG graphs over here that we've created. I've created here a new folder, which is BPPCG, just for the testing purposes. And now I'm going to hook up the PCG basic graph that we've created. I'm going to drag and drop it over here. I'm going to compile. I'm going to save. And I'm going to drag and drop my BPPCG over here. And right now we don't have anything over here spawning. And this is because the PCG component, it is not enough only to be there. We need to add a collision box. So I'm going to hit the add button and I'm going to search for box collision over here. And this box collision is pretty small right now. So I'm going to scale it up all the way to 200. I'm going to compile and save. And right now our PCG will work. So our PCG is working right now with a collision box. And if I move it over here, it will spawn my PCG components over here. If I move it above, let's try for Z50. So I can move it up above and you can see it is not working over here. And when I start intercept with my landscape, it start works. All right. So this is controlled by the Z axis, which is our up axis. So right now we are using this box collider, but we also can use any kind of mesh. So if I hit here the add button and if I add a sphere over here, we can also use this sphere as a collision mesh, which will define different properties. So let me move this sphere. Let me zoom here. Let me move it all the way to the side. Let me minimize a little bit so you can see it. And right now I'm going to compile and save, and you don't see anything. This is because I need to hide my sphere. So I'm going to search for hidden, and I'm going to hit it into my scene. I'm going to press G on my keyboard. And right now this is spawned in a spherical shape. And if I start moving things around, you can see how I'm spawning this pack of trees, but in the shape of a sphere. All right. So this is something else that you can do. You can create custom shapes. Let me just shrink this like that, compile and save. You can create custom shapes, even not in Unreal. For example, you can use Blender or so on to define the shape where you want to spawn your actor over here. The next thing that I want to show you is how you can connect blueprint variables from the BP variables and connect it to the PCG. So I'm going to create one variable over here. I'm going to hit plus, and I'm going to define my PCG graph max scale. This will be my variable, PCG graph max scale. I'm going to use a float because it's a number. I'm going to compile and save. And the next thing is to go to my PCG graphs and open my PCG basic graph over here. And here what we have is we have our surface sampler, we have our transform points, etc. And what I want here is to control the scale max. All right. So how to control this? We're going to search for a node which is called property to parameter. This one, property to parameter. So what this will do is it will get the property from our blueprint, this one, this property, and it will give it over here to the scale max. We're gonna redirect the variable over here and pass it over there. The one thing that you need to do to redirect the variable is you need to make this variable public. So you can do that by clicking here on the eye icon, or by going here and click instance editable. It's the same thing, the eye icon or here, and now you're making it public. So making it public will give access to the PCG. I'm just gonna copy this variable. And here in the property to parameter, we have property name. Right now it is public. We click on the eye, compile and save. And now I'm gonna pass the property over here by putting the name of our variable over there. And right now we don't have warning, and I'm gonna connect it to scale max. And this is how you can give variables to your PCG component, and you can do crazy stuff over here. For example, this variable can be hooked up to event graph here with your blueprint, and it can work with the blueprint, and the PCG can be fed up with the data over here. And right now they're pretty small, so I'm gonna open my blueprint over here. I'm gonna go to my variable, and I'm gonna set up the default value to be 1. I'm gonna save and compile. And from this default value, I'm gonna start tweaking the data. Here, when you select your BP PCG in Unreal Engine, you can scroll all the way here to the default values. And this is the value that we add, PCG graph max scale. And if I start tweaking it, we have real-time tweaking of our trees. All right. This is a cool way to create something pretty interesting. And of course, if you want, you can go back to this graph and you can put this variable somewhere over here in the density filter, and you can filter, let's say, only the pure white trees, and you can just scale them, and you can create different default values over here. One for the let's say pure white trees, maybe it's an oak, and next maybe you have some palms and you want to scale them differently, etc. You can do that by adding property parameter to data, hook up some load variables over here and control it. So this is how you can make the connections between your PCG and your blueprints. All right, let's continue on with the next. All right, everyone, so we've covered a lot of topics. I want to show you how you can spawn mesh on top of your current mesh. And right now we're going to create a rock, and we're going to spawn some bushes on the top of the rock. This is very common from the demo of Unreal Engine 5 PCG. And let's create this. First, I'm going to create a new PCG graph, and I'm going to call it PCG mesh spawner. All right. So this is my PCG mesh spawner. And the first thing that we need to do is, of course, we need to surface the sample on the landscape. So I'm going to right click and search for surface sampler. Surface sampler. I'm going to connect it to my landscape over here. I'm going to hit Q on my keyboard in order to align them. And on this surface sampler, I'm going to stay and hold everything on default. I'm just sampling the surface, and let's drag and drop this one over here. Let's move it a little bit up, and let's try D to debug. All right, surface sampler is working. The next thing that I want to do is I want to filter out only the white ones from 0.9 to 1, so I can have few rocks over here. All right, so let's do this. So right click, density, filter, this one under filters, density filter, and I'm going to connect it to my surface sampler. I'm going to hit D to stop debugging this one, and I'm going to hit D to start debugging this one. The settings for my density filter will be 0.9 and 1 because I want few rocks to be spawned. So let me check this out. Have few rocks over here. I'm going to put 0.95 to get rid of some of the others, and I'm going to use a little bit of seed in order to randomize a little bit more my points. Let me just try a little more. I'm aiming now to have closer points. So let me try 0.98, 0.94, 0.97, 0.96. All right, 0.96, and randomize a little bit more with the seed. This is something that I like. All right, 4 points. Pretty cool. Okay, so we have surface sampler. We filter out the rocks over here. And then I'm going to apply a little transform point. And this transform point will give a little variation in my rocks over here. So let's add this by right clicking, transform points under spatial. And let's connect my transform points over here. And the thing that I want to do is I want to use the scale. Let's put, let's say 0.4, and I'm going to start debugging this one. This will be my smallest one. And let's try with a rotation of 360. See how this works. Let's try 0, 360. Let's try 90. All right, I'm going to put 360 so we can have different variation in the rotation. And this is the thing that I do with the transform points, just a randomization. Nothing fancy. I'm going to get back here once we start spawning the meshes. And the next thing is, let's start spawning the rock. So I'm going to right click and search for static mesh spawner. Static mesh spawner. This is the node that will start spawn meshes onto our landscape. Let me move this a little bit up. And here from the mesh entry, I'm going to add my rock that I want to spawn geometry on it. So I'm going to open the descriptor over here. And here in the static mesh, I'm going to go to my Megascans, and I've already downloaded a bunch of 3D meshes. And I've got this forest rock wall. You can see the code over here if you want to download the same. And it is a little bit cut from one side, but I don't care. I'm just making an example. So I'm going to drag and drop it over here. And as you can see, we start spawning those rocks over here. All right. Okay, pretty cool. And I don't like the size of it, so I'm going to use the transform point, and I'm going to put 0.4 so I can have them a little bit bigger. Let's try with 5. All right, 5 is cool. Okay, let's try with 180. Let's imagine that I'm creating rocks for a background, which the player will see only through that camera angle. So this will be cool, and you're gonna not see this code backside. All right. So looking pretty good. Let's continue on with the next step. So let me go back to my spawner over here. And now, oops. And now we have our static meshes spawned over here. The next thing is we need to add points to those static meshes in order to tell where to spawn grass, bushes, trees, etc. So there is a node called mesh to points. I'm going to right click mesh to points. And this node will add points to a specific mesh. And right now, the mesh I need to put is, I need to go here at my forest rock, and I need to drag and drop the mesh over here. So after we added the mesh to points, when you hit the book here on the mesh to points, you should see here different cubes over here on the mesh, but it's kind of buggy, and right now I'm not connected to the static mesh spawner, so right now we don't see anything. But let's do a copy points, which will transfer my static mesh spawner and my mesh to points, and we'll combine them. So I'm going to search for copy points. This is the sampler. And for my source, I'm going to feed with my mesh points, and for my target will be my static mesh points. Let's debug this one. And right now we can see the points over here. All right. So the reason that this didn't work is because we didn't reference it with the static mesh spawner. And next, right now, as you can see, we have those points everywhere on our mesh. And we should face and place the points only based on our normals, and we want our normals to face the z-axis. So we're going to do a normal to density. So I'm going to right click and search for normal to density, and I'm going to connect my normal to density over here. I'm going to start debugging it, and let's see what I have here. We have the white points over here, and the black points are over there. Right now we are facing the this axis, the z-axis, so we're facing the up axis. If you want to change it and face, let's say, the x-axis, you just need to put 0 for our z-axis and 1 to our other axis, and you can start spawning things over here. For example, you want to make a hanging trees over here or something like that. You can filter it by using the normal to density. So let's say we're spawning some grass over here. We can filter this out. We can spawn some grass over here. We can create a spawner and spawn some grass. We can duplicate this. We can get it out and we can spawn something on our z-axis over here. We can spawn here trees. We can spawn some hanging leaves over here, some hanging grass over here. So this normal to density is pretty useful, and you can create different variations using it. All right. The next thing that I want to do is I want to create a little density noise over here. So I want to create a little variation. So I search for density noise, this one, density noise. And let me connect it over here. And for my density noise right now, I'm going to use the multiply section. Multiply. So I'm multiplying a little bit noise of it. And I'm going to start tweaking the min and max. I'm going to put 0.3 or 0.4. Let me just show you what it does. 0.4. I'm just changing a little bit the color over here, those gray areas. All right. I can do 0.0. Yeah, I will leave it to 0 and 1 so I can add a little variation over here. I can always come back later on when I spawn my meshes and fix this. And the final touch that I want one more filtering. So I'm going to do a density filter again. Density filter. And I'm going to filter these areas from 0.5 to 1. Let's try it. Yeah, here are the points, as you can see. So I can have fewer points. And I'm going to tweak when I spawn the mesh. This is my next step. I'm going to static mesh spawner. All right. And I'm going to spawn something over here. I've downloaded this grass and I have some bushes over here. Let's try with this one first. So I'm going to go to my mesh entries and I'm going to add this one over here. And as you can see, we started spawning some meshes over here, which is pretty amazing. You have some trees over here hanging, rooting from there. But right now I see a lot of problems. Like the first one is I have a lot of homogenic trees over here, and they don't look pretty natural. So what I'm going to do is I'm going to transform some points before I do the static mesh spawner. So transform points. I'm going to connect it over here. I'm going to disconnect this, connect it over here, and start playing around with it. So I'm going to put 0.1 and here 0.4. Let's try with 0.5. Let's try with 3, 2, 1.4. So I'm going to end up with 0.2, and this will be 2.2, something like this. Right? So we have some small trees over here. We have some big ones over here. All right. That looks pretty cool. And I'm going to play a little bit with the density filter. Let's try with 0.3, 0.6, 0.45, something like this. And in the transform point, you can also apply a little rotation, let's say 90 degrees, which will be my rotation max. So this is how you can spawn different meshes onto your other mesh and create this variation of the nature. Of course, you can go here at the mesh spawner and add one more component, for example. And let's add a little something different. Let's add this one. Let's add this one over here. And we are filling up our cliff with a lot more dense grass over here. So as you can see, we've created a little variation over here. And these cliffs look pretty good with a little grass on them. Of course, you can tweak this, you can scale it, you can change everything on it, but it looks pretty damn good. And this is how you can create and spawn mesh onto your mesh. This is something that Epic Games did in their demo. Of course, as I told you, if you open your spawner and here with the normal to density, you can branch this and you can start spawning some grass over here, hanging grass, and create this variation, this nice variation in your environment over here. All right, so this is something very cool that we've done, and let's move on with the next topic. If you want to support this channel, gain access to all my assets, join my Patreon now. All right, everybody, so we've gone through all the basics that you can do in order to create this PCG forest, and combining all of those things that I mentioned before will lead you to this forest. I'm just gonna break down how I've created this forest. This forest is available to my Patreon members, so you can download it. So I'm just gonna break it down because it is quite time consuming, and if I start creating this forest from scratch, it's gonna take maybe few more hours, maybe 3 or 4 hours extra. So I'm just gonna go through all of my here subgraphs. I'm just gonna go over to my tools, and here on the BP Forest and PCG Forest. Here at the nodes I have few blueprints to apply density and to apply height to density. So let's just start. I'm just gonna explain pretty quickly each PCG subgraph, and I'm gonna show you the connections over here so you can replicate them. But I'm not going to go too much in details because it's gonna take a lot of time. So if you just want to straight download this and use it, join my Patreon club. So let's start first with the PCG bushes. I'm gonna double click here, and here is the graph of the PCG bushes. So here from the input, I got going from the landscape into the project points on landscape. So I'm just projecting points on landscape. Here, the get actor property, I set up the bush density. So here we can control the bush density of our forest. And this property name is under our BP forest over here. And here you have the bush density, here the float. This is the one that will control the density of the bush. And let me show you where this is. Here is the bush density where you can set it up. We've also have a button over here so we can turn it on or off the bush density. And the bush density is from 0 to 1, okay? So you can control it from here. Then when I do this, the get actor property, I set up a little density filter with the lower bound of 0.5. And then here at the bottom, I'm creating a points grid with those info, 500 for the grid extents and 100 for the cell size. Then I do some transformation on the points. Then I go to copy points from the density filter and combine the transform point. The transform point of the point grid is connected to the source, and the density filter is connected to the target. After that, I connect everything to the projection point of the landscape. So the landscape is connected to my project points on landscape, and points to project are the ones that we've created from the point grid. All right. Then I move further and create a distance node, which will use the target, our density filter, and our get actor properties, which is the density of the bushes. And then I connect the source, the points that we've projected on the landscape over here. Then I go a little bit crazy and just tweak everything with density remapper. I do scale by density, then a little density noise, a little density filter, some transform points just to change everything. And here in the static mesh spawner are the bushes meshes that I want to spawn over here. So I have just two of them here, two different bushes. Of course, you can place some others and you can tweak the weight. And after that, I put a bound modifier so I can have bounds of the spawning of those bushes. And the bounds are between minus 120 to 120 with a steepness of 0.5. Just gonna go pretty quickly around here from my distance so you can copy the options. Here is my density remap, my scale by density, my density noise, my density filter, my transform point, the static mesh point, and the bounce modifier. So this is pretty much about the bushes, all right? Moving further, let's go with the grass over here. We need first to create all the nodes, then we need to create the forest data, because the forest data and the forest itself are having subgraphs in them. So this is about my grass. Again, I have a landscape over here going to the project points on landscape, and here I have another actor property which will control my grass density from my forest. Over here we have a grass density, and my grass density is, let me just go back a little bit. Here is my grass density. Again, I'm just putting here the variables setup. I do a select, and then I connect my select to my grass density. I select this is a construction script, and I select my boolean to control the select over here. All right. So let's go back to the grass itself. Here is the grass. So I create point grid. Here I create this variable grass density. I connect to the density filter, and this will control my upper bound of the grass. Then I do a transform point. I do a distance to density. Then I copy all the points from the input over here going into the target, and everything here is going to the source. After that, I do some transformation of the points to create some variety in it, and then my project points on landscape is connected to my landscape, and it's connected to my points to project. All right. Then I do again a transform point to create a little rotation here, 360. Then I do difference. Difference will cut the source and the mask of the input. So here in the input, I've created one custom pin, which is called mask, which we are going to use later on so we can filter. And so with the difference, the source is going from the transform point of project points on landscape, and the difference is the mask that we've created here in the input node. Then I go with the density remap, scale by density over here, a little self-pruning so I can prune some of them, of the grass. Then I go to the static mesh spawner. Here at the static mesh spawner, I have this plant grass ground over here, just one of them. Then I go to the output. So this is pretty much about the grass. The next one is the PCG scatter. So the PCG scatter works like this. We have a scatter grid extent over here and a scatter cell size. So I've created two variables that are attribute set over here, and I've connected them to create points on grid. So we are creating points on a grid. And from the input, I go to a copy points node over here, connect my create point grid over here to the source, and the target is the input. After that, again, project points on landscape, connect the landscape, and connect the copy points to project. After that, I go to a distance node, which will have in here in the target and the distance point in the source. After that, I do some transformation just to change the rotation of it with 360. Going further, scale by density with those settings, scale min 0.27, 0.25, scale max 1, and then I connect it to my output. So this is about the scatter, nothing fancy, just keep in mind to create this custom pins over here, the attribute set, and the scatter grid extends, all right? Then continue on with the plants. For my plants, I have normal to density. This normal to density is from the execute blueprint. So you drag and drop execute blueprint and search here for normal to density, this one that we have, and you can create this node. After you create the normal to density, this is the setup that I'm using. Then I go to a density filter just to filter from 0.6 to 1, a little density noise, again, a little density filter with 0.99 to 1. I do some self-pruning, this for my plants, some transformation of the points, some scaling and some rotation over here. Then I go to the static mesh, and in my static mesh, I have these plants on the ground. All right, so this is pretty much about my plants. And the next thing is the shrubs. Here, the shrubs are a little bit more complex, but the logic is the same. I have a property actor, which is shrub density, and this is into my forest. Let me see where it is. Here it is, shrub density, and the block is the same. Here, shrub density, set, selector, and boolean for it. Let me just go back. Then I go to a density filter, I copy the points, get it from the input to the target, and the source is here the density filter. Go to transform some points, those are the values that I use, and after that I create a distance, which the minimum distance will be 500 for me, and I connect it to my input, and the source is our transform points. So the input here is our target, and the transform point is our source. Then I go to density remap, scale by density, density noise, all these are tweaking, density filter with those settings, self-pruning. I do a project point on landscape, so I'm projecting those points on the landscape, and you need to connect your landscape over here. And for the points to project from the self-pruning block, you connect it over there. Then I do some transform points, and here I've created 3 static mesh to spawn and a bound modifier. So the first static mesh to spawn are some grasses that I've downloaded in my Unreal Engine. And then I do some transform points density filter and spawn those flowers in order to break up the ground over here. As you can see here, we have some flowers. That is why I've created 3 different static spawners. So the first one will hold different varieties of grass. The second one will hold different variety of flowers. And I have here another variety of flowers. And the idea behind this is I need a different scaling per each, and then I do a little density filters in order to filter those flowers. And this transform point is working on my static mesh spawner, which is the grass. Then I do a bound modifier in order to put bounds on it and put it into output. Moving further is our shoreline. This is when you place water inside your level and you have a shoreline at the border of the river or the lake. So here I have a property actor, show on shrubs density. So we have density in the shrubs. Again, it is over here like a float. And let me just see where it is. Here it is, show shrub density. All right, let me go back. Then again, I'm gonna do some density filter. I'm gonna do a distance with the source of the density filter, and target will be water. And here at the water, I choose points and I label it water. All right, so this is the water that is going to work on our shoreline. Then this is the distance, and the maximum distance is 500. This is something that I found out that works good, the distance. And then I go to the density remap, density noise. Here are some modifications, density filter, those are the settings. I do some transform points, and then I project points on the landscape. So right now I'm projecting the shoreline onto my landscape over here, connected to the landscape, and points to project are connected to my transform points. Then I do some transform points, and here I spawn the flowers or the vegetation that I want to spawn in the water or near the shore of the water. All right, so this is the shoreline. Next, I'm going to show you the water. So here at the PCG water, I have this get spline data, and I put it by class over here and selected water body river class over here. All right, so this will start filtering the water body river class from the Unreal Water plugin. And get spline data, here are the lakes. Then I do some rock shoreline over here with spline sampler, 2 spline samplers actually, so one for the lake and one for the river. I do union, which will combine those 2 spline samplers. Then I do some transform points, some density noise, density filter, and again some transform points. For the volume of the water, I do 2 spline samplers again for the river and for the lakes. And then I do some transform points in order to transform those splines over here and do a union. After that, I put everything in the output for my rocks, and this will work like a mask for the volume of the water. And this will spawn my rocks at the shoreline, all right? And I do some, the first one is rock with points, and the second one is mask again with points. So this is pretty much how this PCG water will spawn rocks, and we will have the mask of it. Now let's continue on with our PCG path. For our PCG path, I get spline data over here, and I've put the tag to path over here. All right. From the spline sampler, I've created a spline sampler here, and I have a distance increment of 201. Then first is my mask, which will be the transform point. All right. And then this transform point go all the way here to the output. But the interesting part is here for the randomization of the points on the path. So I create a point grid, I do some transformation on that point grid, and then I get a pebble density. So those are the pebbles that I'm spawning onto my road. You can put any property name over here. Then I do a density filter, And here from the output of the spline sampler, I do some transform point, a union, and then I start copy the points from the density filter over here for the grid point that we get, and from the spline sampler over here. So we copy the points. Then I do a transform point, and here at the input, which is in our PCG, I connect my landscape to my project point on landscape over here. Then I do some transform points, and we start spawning some pebbles and some branches, tree trunks, etc. Those are just defining names for me. You can spawn whatever you like over here. So I go from the transform point to a density node. I do some filtering, some transform point over here, the same density filter and transform point. And those are for my different rocks. Here I have a static mesh spawner with some rocks. Here are different rocks. And here are my branches and tree trunks. So I do a density noise, density filter, transform point, static mesh spawner, where I have some branches over here. So in the detail plans point calculations, we are creating a mesh to point, and I just reference my fallen tree as a mesh. And then I copy the points from the static mesh spawner over here and from mesh to point. So we are creating a mesh grid around our tree trunk. Then I go normal to density, do a get actor property with detail plan density. So those plans are around our mesh, as I showed you with the cliff and the trees. Then we do a density noise, density filter, and connect everything to the detail points. And my detail points are using point. Moving further along is our forest data. I know I'm speeding up this, but the idea is just to check out my notes and recreate them. You can pause at any point because this will take a lot of time to recreate again. So for my forest data, I get a spline data and I call with the tag biome mass. I have a spline sampler here for points of the forest, and I have a spline sampler for the edge of the forest. Then I go to the edge transition with a distance field of 2200. For my source, I got with my points of the forest, and for my target, the edge of the forest. Then I do some union, some transform point, apply density to height over here, the node that we've created with the blueprint. We have here for the edge transition of the water a distance, apply density to height. And of course, for the target over here, we get the water mask. And here at the water mask, I'm going to show you the water mask is point based and path mask is point based. Those are the things that are going to cut through the forest. All right. So we have here a distance, we have applied density to height. Then here we cut the water and the path volumes. We get the water mask and the path mask. We connect it to the union, and then we do a difference. Difference will start cutting. So we start cutting here from the source, which is the edge transition of water and the edge transition, and making the difference with the masks over here for the water and the path. All right. Then we put some stuff on the landscape and randomize them with project point on landscape, connected to my landscape over here to the input. And then I connect the difference to my points to project. Then we do height to density with max height of 2000, transform point, and connect my output. Let's move to the trees over here. So for the trees, we have an input to the transform point, and the get actor property is the density of the trees, how we want to spawn them. Then I do a density filter, connect my variable to my upper bound, ignore those errors over here. Then we have a density noise, and this density noise will go to my high value trees and bushes. Then we have lower trees and grass. Then we have shrubs over here. So let's start with the first one. The high value will be trees and bushes. So I have a density filter, and here I have my tallest trees. My tallest trees are connected to the bushes because we want to spawn bushes over here, and those are connected to the landscape. So we've already shown you how you can drag and drop subgraphs over here. Just select your let's say bush over here. Let's see, where is the bush? Where is the bush? This, drag and drop it like that in the graph, and you're gonna have this node over here. Then my second one is tree and grass. Again, density filter, static mesh spawner with some smaller trees over here. I have two pieces of trees. Then I connect to my PCG grass. My PCG grass is connected the in to my static mesh spawner, the landscape is to the landscape, and the mask is connected to my shrubs. And for my shrubs, I do a density filter, bounce modifier because I want to have a bound for my shrubs. I disable the self-pruning over here. I've just tested out, but without self-pruning it is better. And then I connected my PCG shrubs. And my PCG shrubs are going to the mask of the grass. This is pretty much how I've created the tree node. Few more left to check it out, so let's move on to the rocks. The rocks are again transform point. From the input to the get actor property is rock density, just like before, a density filter with upper bound and transformation point. Then we have a bound modifier with those settings. And from bound modifier, I go to the static mesh spawner, where I start spawning my big rocks over here. So here we have create points for the detail plans. So we are creating some points around the rock for the detail plans. We have a bound modifier. We are copying the points. Mesh to the point is our rock. So we are getting this mesh and we are start to creating points onto that mesh. All right. We are copying the points from the bound modifier and the mesh to points, adding a density noise. And this is detail plans density. All right. This is adding to the density noise. Then density filter. Let's move to the smaller rocks. We are creating a point grid with a transform point connected from my bound modifier over here. Go to copy points, source and target, then do some transformation. We do project point on landscape and we connect it from the landscape over here and it's going to the project points over there, and the transform is going to the points to project. From transform points, I do another transform points in order to create variety based on the distance. So here I have source and target and I have this maximum distance. Then I do some density noise, density filter, density remap, again density noise, I scale them by density, I do some density noise, density filter, transform points. Everything here is just to break up, not to look similar. Then I do another static mesh spawner with another rock, different this time. And everything here is connected to my spawn points for smaller rocks, all right, which is the final node that I've created. So from my density filter over here, I go all the way to my union over there. But here I create a mesh to point, get actor property, which is the detail plan density. Then I do a density noise, I do a density filter, I copy the points, the source is over here, and the target is our small rocks, all right? Then I do again a density noise, density filter, we connect the union with our create points for detail plans, and then we go to the output, which is our detail points over here at the points, all right? So this is pretty much the node for our rocks. And the final one is our PCG Forest. This is the combination of everything. I've put my forest data over here and I connect my actor, my in and actor over here to the forest data. My landscape is going to the landscape. From the PCG water, I've put my mask over here to the water mask and I've put my path mask from the PCG path output node. All right. The output node for the path is connected also to the landscape. And we have PCG shoreline, which shoreline needs the mask for the water. We connect it to the landscape so we can create the shoreline based on the landscape, and the forest data is in my input. All right, from the forest data, we have a little self-pruning, density noise, density filter, density noise, and density filter, just to break up everything. Then from here, we do a union between our forest data and our PCG water rock layer. All right, union between those two. After that, we go to the PCG rocks, which is connected to my landscape and to my union, and the PCG rocks are going to a difference. So we are creating difference between the PCG rock and the forest data from the self-pruning over here connected to the source. Moving further, we have a union between my rocks and between my path, so we can create a union between them, and then we connect them to my PCG plants. And finally, we need to create the trees. The trees are connected to my difference over here, and they're also connected to my landscape. So this is how my forest, my PCG forest look like. Let me just move it pretty quickly. All right. The next things are my BP Forest blueprint. Here is the BP Forest blueprint, what I have here. I have for my component a PCG, a box, and a default scene root. This is my PCG actor. I've added it from here. You search for PCG. Then I have a box which will define my collision, and I have the default scene root. So I have two groups here. I have enable detail plans, enable shrubs, and I'm gonna go through all of them. Those are turned off right now by default. I have short foliage, I have detail plants. You can enable and disable them. You can enable the paths, enable the trees, and enable the rocks. Those are the booleans that I'm going to use. And here are the floats in order to control the select node over here. And everything is connected under a construction script. So I'm connecting enable detail plans to a select node from 0 to 1, and I set up the variable, the float variable over here. I do this for every boolean and every float. All right, so this is my BP Forest. The next thing is my BP Road. My BP Road construction script looks like this. I get number of spline points. I have a variable which is a spline component to the target. Then I subtract -1. I do for loop, so I'm looping. And I get location at the spline point over here. For my point index, I get the loop here, the index, and I connect my spline over here. Next, I have a vector node here at the return value with z of 500, and then I add to the billboard component, which have the relative transform location, which is connected to my relative transform location and to my for loop node. In my viewport, I have a spline over here created. And very important thing is when you click on the BP road and search for tag, you need to put the correct tag so it can start filtering out. So I put path over here. And the final one is my BP Forest. I put a circle spline over here. Let me just move it like that. All right, I put a green cover. I put a billboard with an icon over here. And on my BP Forest itself, I put the tag biome mass. All right, and here I have the billboard, the spline, and the default scene route. I don't have anything in my construction script under my BP Forest. Alright everybody, so this is how I've created this forest. I go through all the nodes pretty quickly because it will take a lot of time to recreate them from scratch. I hope you can pause the video and just recreate it yourself. And before I end up this video, I want to let you know that I've created a Blueprints Masterclass for Unreal Engine 5. It is available right now on Udemy. So if you want to expand your knowledge and not just only create art pieces in Unreal Engine 5, but create some characters, create some game logic, my course is the perfect solution from beginners to intermediate Unreal Engine 5 users. The course itself is 15 hours long and it has all the foundation that you need to kickstart your blueprint knowledge in Unreal Engine 5. So if you want to keep evolving yourself beyond just creating art in Unreal Engine 5, enroll now. So I hope you enjoyed this video, and if you want to support me and get access to all my files, also to the auto material that I've created previously, join my Patreon page for $4.99, and with your pledge you're supporting me to keep creating amazing videos like this. Each one of you can make a big difference by supporting my channel so I can keep making those videos. Thank you guys for watching this video. Happy game development. I'm out.